Okay, this is Module 5, Lesson 14, and this is our learning objective today. It says, I will be able to compare two fractions using common units. Common in this case just means the same units. And today we're going to be using numerators, common numerators, and if you recall, numerators in a fraction is the top number. And also common denominators. In fractions, the denominator, is the bottom number. So we're going to be looking at common numerators and ways to compare fractions using common numerators and also using common denominators. We've talked a little bit already about how to find common denominators. Today we're going to be looking at fractions with common numerators. Okay, so now I am on page 67, lesson 14 problem set. And in looking at this whole page, what you're really looking at is common numerators here. And I'll explain what that means in a second. It says, compare the pairs of fractions by reasoning about the size of the units used, greater than, less than, or equal. Well, all we're doing here is we're looking at 1/4 versus 1/5, right? So 1/4 versus 1/5. Well, my numerators are the same, so I'm going to look at my denominators and think in my head, well, are fourths bigger or smaller than fifths? Fourths, I know, are bigger than fifths. So 1/4 is larger than 1/5. Okay, so let's maybe move down to D. Same kind of thing. 7/10 compared to 7/12. Well, my numerator is the same, so I'm going to look at the size of my denominator, and I know that tenths in fractions is larger than twelfths. So 7/10 must be larger than 7/12. Okay, so that's kind of what to do for those. This bottom section on number 2, it says, compare by reasoning about the following pairs of fractions with the same or related numerators. Use greater than, less than, or equal. Explain your thinking using words, pictures, or numbers. Problem 2B has been done for you, and that's that one right there. Let's do A first. So what I'm looking at here are two fractions, 3/5 versus 3/4. This is just like the problems we did up here. My numerators are the same, so I can look at the size of the denominator. 3/5, I know that fifths are smaller than fourths, so 3/5 must be smaller than 3/4. Same thing here at C. C says 7/11 versus 7/13. They have a common numerator. The numerators are the same, so I can just look at the denominator. Well, I know in fractions, 11ths are larger than 13ths, so 7/11 must be larger than 7/13. Okay, and B and C, or B and D rather, are a little bit different. And we'll look at the example problem in B first. So they're comparing in B 2/5 versus 4/9, right? And I see that my numerators are not the same and our denominators are not the same, and it's really going to be hard to find a common denominator here because I can't really multiply anything to get 9 here. So what I'm going to do is I'm going to try to find a common numerator. And I think I can find a common numerator by multiplying my 2/5 times 2/2. And I'm going to see how that works in a second here. So that's kind of what they did, is they first modeled with a tape diagram 2/5. So you can see the tape diagram here with, this is fifths, 1, 2, 3, 4, 5. And then 2 of those are colored in. And then to get a common numerator, what they did is they divided their fifths into 2, right? So now we have tenths, right? So our 2/5 became tenths. And how many tenths did it become? Well, let's count up the tenths. 1, 2, 3, 4. 4 tenths, right? So 2/5 times 2/2 gives me 4 tenths. 2/5 is the same as 4 tenths. Well, now I can compare my 4/9 to 4 tenths, right? So I can look at 4 tenths now versus 4/9. And I know in my head that ninths are bigger than tenths, so 4/9 must be larger than 4 tenths. Okay, so you're trying to find a common numerator with these two. Similarly in D, I don't have a common numerator. I don't have the same numerator in these two fractions, and I don't have a common denominator. And I can't easily figure out how to get a common denominator because I can't multiply 7 by anything to get 15. But I can find a common numerator. I can already tell I can multiply my 6 times 2 over 2 to get a 12 up here, and that'll help me compare. So let's go ahead and do that. So let's look at 6 sevenths. Oops, 6 sevenths here, times 2 over 2, and that gives me 12 fourteenths, and I can compare that to 12 fifteenths, right? And I know in my head, fourteenths are larger than fifteenths, so 12 fourteenths is larger than 12 fifteenths, or 6 sevenths is larger than 12 fifteenths. The way that works in tape diagram world is this. So we'll start with our 6 sevenths. So I'm going to start with sevenths. 5, 1, 2, 3, 4, 5, 6, 7. And then I'm going to color in 6 of those. Okay, there's my 6 sevenths. And then I'm going to multiply that by 2, meaning I'm going to divide each of my segments in half. So now I get fourteenths, and I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fourteenths. Okay, so that's kind of how that works. Okay. Now, on this one, we're going to actually use what we call common denominators. Common to figure out how to compare the two fractions. And so we have problem number 3, which says, draw 2 tape diagrams to model each pair of the following fractions with related denominators. So I can see in this problem, I got 2/3 versus 5/6. Well, my numerators aren't the same, and my denominators are not the same, but I can see that I can easily convert my thirds into sixths by multiplying times 2. 2/3 times 2 over 2 gives me 4/6. And I can compare that to 5/6 pretty easily. And now I have common denominators, and I know that 4 is less than 5, so 4/6 is less than 5/6. In tape diagram world, this is what this looks like. And I'm going to say, if you feel like you're comfortable with this method, the multiplication method, you don't need to draw your tape diagrams. However, if you're not comfortable with what to multiply up here, go ahead and draw your tape diagrams, because it'll be easier to sort of show your multiplication using tape diagrams. Okay, so now what I'm going to do is to draw 2 identical tape diagrams. It really helps if your tape diagrams are basically the same size, because what you're going to do is model the 2 fractions and just look and see which one is bigger. So here we go. I'm going to start with 2/3. There's my thirds. There's my 2/3. Now I'm going to model 5/6. Well, that's pretty easy. I have my thirds, and then I can just cut those guys in half, right? And now I have sixths. 1, 2, 3, 4, 5, 6. I'm going to color in 5 of those guys, and I can just see visually that this 2/3 is less than my 5/6, right? So 2/3 is less than 5/6. Okay. All right. And by the way, if you wanted to sort of see the 4/6 on turning your 2/3 into 4/6, all you'd have to do is do the same thing up here, right? And then you can see that your 2/3 is the same as 4/6. There's 1, 2, 3, 4 of the 6, 4/6 versus 2/3 are the same fraction, right? Okay, so B, let's go ahead and do B. 3/4 versus 7/8. My numerators are not the same, but I can see that I can easily change my denominator. So I can turn my fourths into eighths pretty easily by multiplying times 2 over 2. 3/4 times 2 over 2 gives me 6/8, and I can compare that to 7/8 because I know 6/8 is going to be less than 7/8, obviously. In tape diagram world, I'm going to draw two identical tape diagrams. It's pretty close. I'm going to model each of these, so 3/4. There's my fourths. I'm going to color in 3 of those guys. Okay, there's my 3/4, and now I got 7/8. Well, eighths are easy. I can just copy my fourths and then divide those by 2 to get eighths. And then color in those guys again. 7. And I can see that 7/8 is bigger just visually than 3/4. So 7/8 is bigger, right? And I know over here exactly how much bigger because I modeled finding out how many eighths 3/4 is, and I know it's 6/8, and I can show that on the tape diagram if I want.